Here we are. Description. Again, Bernie, once I switch to my presentation mode, I won't be able to see anybody. So if they've got questions, please interrupt me, or so you'll have to unmute for that.
Will do.
Okay, I'm going to bring my screen up. Okay, is that a full screen now? Thank you. Okay, it's a couple minutes after, so what we'll do is get started. And if anybody joins us late, that's fine. They can join us whenever. I'm going to minimize you guys. All right. Hi, I'm Terry from ChemAqua. I head up our healthcare and environmental division across Canada. I've been with the company for 31 years, so I'm old, but I also know a little bit about Legionella, and I've worked with right across the country with all kinds of different companies on helping them out. Bernie's also with me today. You guys are probably all familiar with Bernie. He's your local manager, and he will be helping me do this. And if you've got any questions, feel free to interrupt. It's a smaller group today, so just interrupt, but I can't see you, so you'll have to talk out. Putting up your hand won't help me, but Bernie's going to watch in the background if that happens. So it is 5 after, so we'll get started. We'll still get you out of here just a little bit early, so if all goes well. All right, so Legionella minimization. It's more than just adding biocides. There's more to the programs. What's going on? Sorry, I'm having some technical difficulties. Okay, there we go. So like I said, I'm old. I've been around for a long time. So let's do a quick little history on Legionella and where it came from. Back when I started in the industry, we used to treat all the cooling towers with chromates. Chromates were awesome. They provided great corrosion control. You would never get any corrosion or rust, but they also killed everything. So there were all the bacteria. So there was no microbiological controls needed on top of that. Now, unfortunately, not only did they kill bacteria, but they killed everything. So in the 70s, the EPA made regulations restricting the use of hexavalent chromates. And in the 80s, they outright banned them. Anybody that's seen the Aaron Brockovich movie knows all about that. Well, that left the water treatment business in a little bit of trouble because when we took away the chromates, we had to design new ways to prevent corrosion for the equipment. And we came up with the organophosphonate-based control for corrosion. But they did nothing for the bacteria that were in the water. So that's when we had to start adding biocides to the water to treat cooling towers. Now, surprisingly enough, coincidence? Right in that mid-70s was when Legionella bacteria was discovered. A Legionnaires' convention in Philadelphia in 76. I think it was 20 some odd people got pneumonia, but they didn't respond to the normal treatments for pneumonia because it did not have any effect on that pneumonia, and people got sicker and died. And that was the first recorded case of Legionnaire's disease. Now, since then, we've grown a lot when it comes to Legionella. We all know, everyone knows, the cooling towers are a high risk for Legionella. Why? Well, the water temperatures are perfect when the cooling towers are running. I'm going to put my little laser pointer out. There we go. Sludge, scale, sediment, iron. There's always lots of food in a cooling tower for bacteria to grow, even Legionella bacteria. There's always hidden biofilms, and we're going to talk about that a little bit because that's really important to Legionella control. And towers, they're big old air washers. They suck all the dirt in the neighborhood in, including the bacteria from the airs, which provides even more food for Legionella bacteria growth. Well, if they're so dangerous, why do we use cooling towers? Well, it is still simply the most efficient and economical way to pick up the heat from a building, transfer it to that water, and then send it to the atmosphere through evaporation. So it picks up all the heat in the building and sends it outside. That's its cooling tower's only job. Well, unfortunately, with that evaporation, Legionella bacteria can also be in that mist, and people can breathe it, and that's how you catch Legionnaires. Now, we used to think, again, I'm old, if the cooling tower was up 10 stories, 8 or 10 stories, everybody was safe. You couldn't catch Legionnaires. We now know, I mean, Quebec really showed 12 kilometers, up to 16 kilometers away, but proof 12 kilometers away, people breathed the mist from a particular cooling tower and still caught Legionnaires. So it can travel with that mist. Now, Legionella bacteria is not new. Didn't start in 1976. That's when it was discovered. The people got it. It is actually one of the most common bacteria on the face of the earth. It can be in any type of water, fresh water, salt water, groundwater. It can be in the ground or the water that gathers on leaves. It's been around forever, so it knows how to protect itself. It's been proven the Legionella bacteria can live in a hot water distribution loop with 50 ppm of free available chlorine, and chlorine kills it because it loves to hide in the biofilms, which we're going to talk about. Now, the good thing is you can't get Legionnaires from drinking the water. If this bottle of water had a million Legionella bacteria, colony-forming units of Legionella, and I took a big drink, I'm still not going to catch it unless I choke on it and I aspirate it into my lungs. You actually have to breathe the mist of the water that has the bacteria in it to catch Legionnaires. Now, not every single person, by any stretch of the imagination, that breathes some Legionella bacteria is going to catch Legionnaires. But if you're immunocompromised, which is why this is so important in hospitals and seniors' homes, if you're a heavy drinker, if you're a heavy smoker, check, by the way, then you're more susceptible to catching Legionnaires when you breathe it. Now, it can be in any type of water on the face of the earth. But this is Canada. We take that water and we bring it into our treatment plants, and we've got really, really good treatment plants. And a lot of the things that they do will minimize the Legionella bacteria. Chlorine, monochloramines, chlorine dioxides, all very well known to kill Legionella bacteria. However, since you can't catch Legionnaires from drinking the water, they don't necessarily test the water. Well, they don't test the water for Legionella bacteria. Then it leaves the plant and it goes through miles of pipes underground where it becomes, and into your building where it becomes your problem. Now, if we test the water coming into a building, the cold water, almost every time we're going to find none detected, no Legionella detected in the cold water. But then we take it and we put it into what we call amplifiers, the cooling towers, the hot water distribution loops, where the conditions are perfect for Legionella growth. And the equipment, by its nature, distributes that to the atmosphere, and that aerosol gets out, and a susceptible host can breathe it. And that's the only way, again, you can catch Legionnaires. Now, I never know where to put this slide, but it's important. Temperature is very, very important to a lot of bacteria, but especially to Legionella bacteria. Below 20 degrees C, Legionella bacteria is dormant. We used to think it was dead or wasn't alive. We now know it's dormant. Then when it warms up, it becomes viable again. From 20 to 50 degrees C, Legionella bacteria grows. Ideally, 25 to 45 degrees C is the optimum Legionella growth temperature. Well, what else happens in that optimal growth range? The human body temperature. That's why we're such good hosts for it. Nice, dark, wet lungs at the perfect temperature. The average shower temperature is right in that optimum growth. The code says you can't have your hot water hotter than 49 degrees C because you'll scald people. But that is in the growth. And in Quebec, you can't have your water hotter than 43 degrees C. Again, scalding is always going to be a big issue. Now, at 50 degrees C, Legionella stops multiplying. Doesn't die, but stops multiplying. At 60, it begins to die slowly. And at 65, boom, Legionella bacteria dies instantly. However, if we ran all of our cooling towers at 65 degrees, we wouldn't get much cooling and people will get scalded. Now, here's the real secret. Let's talk about biofilm. I've mentioned it a few times. Legionella is a bit hydrophobic. It does not really like to swim around in the bulk water that's in the cooling towers and in the hot water distribution loops. It loves to hide in biofilms where it's protected inside the biofilm from all the things that we can do to it. And it grows inside the biofilm and then sloughs off. And that's when it becomes a safety issue. It's safe as long as it's in the biofilm. So where did biofilms come from? Well, biofilms form very, very quickly, up in minutes, actually, in dead leg and low flow areas of your system. But our system runs 24/7 when it's hot. And I'll be standing there right next to a pump. Oh, well, that pump's not running. Oh, well, that's redundant in case this one breaks. So that pump and that entire line is full of stagnant water where biofilms are growing. Standby chillers. Most places have an extra chiller or it comes on when it's 80 degrees. There are lots of places for biofilms to form in a cooling system and a hot water distribution system. Problem is, these systems are made out of glass. We cannot see it, and by the time you find it, it's usually that's a chiller that's loaded up with bio. It's actually shut down on because of the bio. So you can imagine how much Legionella bacteria is in there. You can only imagine it, though. You have to test to find out. Now, one last shot at the biofilm and where does it come from and how does it affect you? All water contains bacteria, all kinds of bacteria, good bacteria, bad bacteria. Some will hurt you, most won't. And it's live and it's in your water. And live things eat. And when they eat, they poop. And the secretions from bacteria, and especially Legionella bacteria, is a polysaccharide. It's a very gooey, sugary, it is sugar substance that will stick to little cracks in the substrate or drop out and stick on low flow or no flow areas. And it starts to build up. And as it builds up, the Legionella likes to hide inside of that. So it's protected from the chlorines and the biocides and the temperatures that we put into our systems. And it starts to grow inside of it. And the biofilm grows, it actually becomes a very complex community of biofilms in there. There's lots of different types and there's different life forms. There's things called amoebas that are a higher life form that hide in the biofilms. And guess what? They eat the Legionella bacteria. That's good. But the Legionella knows how to protect itself and it lives inside of those amoebas. And as the amoeba eats its food, the Legionella bacteria eats it and grows inside of it. And then all of a sudden you'll have an explosion. And there's films of this, an explosion of Legionella bacteria from the amoeba exploding up into the bulk water. Now, a lot of those colony forming units will just stick in other biofilms. Some will go harmlessly down the drain, but some could go to the cooling tower or the showers and be sent to the atmosphere where people can breathe it. Now that I scared the heck out of you, wasn't that long ago, there was absolutely nothing you had to do as a cooling tower owner or a healthcare place to minimize Legionella. but that has changed. There are standards now, and there's new standards coming out all the time. Quebec was the first one. Well, Hamilton was the first one in Canada to have a bylaw to do something about Legionella. Quebec made it into their code, and it is the law. Every month you have to test it, you have to do certain things. Public Works Government Services Canada, the 15161, is the federal standard. Kills me, but it actually is and it's the only one that says what you have to do and how much you can have before you have to do anything, which I really like about the 15161. A lot of the things are based on it. RBQ is based on it. CSA, we've updated the 317 healthcare. It's in reading right now. It's in public reading right now if anybody wants to go make a comment on it. ASHRAE, be all end all of HVAC systems. I should update this because there's a 23 now, risk management, and they tell you all the different things that you can do to minimize Legionella bacteria. And different provinces and cities are making bylaws that you have to do these things. Vancouver, New Brunswick came on a couple of years ago. Now, Nova Scotia doesn't have any particular bylaw or standard that they have to follow. However, Nova Scotia Health, congratulations, guys. You're not waiting to be legislated. The province has already said, we're going to develop our own Legionella minimization plan that follows all the other protocols and make sure that we're protecting our customers and our clients and our staff. Now, all the standards call for the same things. Basically, you have to identify which water systems you need control of. What's the risk? Because there's different risk areas. I'm not going to go through them all, but a cooling tower is definitely a high risk because of all the things we said. A chill loop. Well, you know what? There's lots of dead legs and stuff, but the chances of aerosolizing that water are very, very slim. So they're not a very high risk. So we have to make a list of all the risk of the equipment. Then what control measures can you do to minimize or prevent, if possible, the conditions that cause Legionella growth? And then you've got to make sure that your plan is running as it's designed to run. Can't just be on the shelf somewhere. Now, every single hospital in Nova Scotia Health has a water management treatment plan. It describes all the chemicals you use in your treatment. It describes the type of equipment you have, the risks, what tests you're supposed to do. More importantly, what control ranges are those tests supposed to be in? And if they're not in those control ranges, what can you do about it? They have a schedule for physically inspecting and cleaning your cooling towers, which is really, really important. And they have a schedule for Legionella testing. Every 30 days, every hospital has to send out Legionella culture samples to be tested. And the plan also describes what to do when you find it. And I say when, not if. Although, with the proper plan in place, we do minimize it. But you cannot eradicate a bacteria. I don't care what bacteria it is, and anybody that tells you can is lying. So what we're aiming for is to minimize the chances of growth and spread. Sorry, I got a bit of a cold this morning. So what do you guys do? And again, feel free to ask any questions, especially during this part, because this is your actual hands-on physical stuff that you guys will be doing for what is your plan. So every site that has a cooling tower has an automated controller with it, control system, chemical feed, and bleed system. The controller measures the conductivity of the water that's circulating in your cooling system. And at a certain point, it opens the bleed so that, one, we maximize the water usage because water is expensive and we have to be conserve where we can. But there's a certain point where water just becomes dirty and we have to bleed it out and replace it with fresh water. The controllers do that automatically. They also feed the inhibitors automatically. So inhibitors are made to protect your system against scale, sludge, and corrosion, and they feed automatically at the right times in the right amounts. It doesn't matter what you feed in if you don't test it and if we don't know what's inside your program, it's inside your water. So for the Chem Aqua people on here, we use the 31155 or the solid Handypack 55 to minimize the corrosion. And we use conductivity as a set point. So the staff, once a week, we 3 times a week minimum, we've asked them to perform some tests. Take a sample of that cooling tower water. Most of these have a Pyxis of some sort, the 400, the 800. You pour the water into it, you press the button, and it tells you what your conductivity is and what your inhibitor levels are. And then you write them down. That's really important. And then Chem Aqua comes in once a month to each site and does full testing and gives you a report. So we're doing all of that, and that's a very, very important part of Legionella minimization. Now, we've also instituted a dual biocide program. There's 2 kinds of biocides that are fed to a system. One is an oxidizer and one is a non-oxidizer. Oxidizing biocides are a bleach type, a halogen. They do 98% of the kill of all bacteria. They're like a big old fire flamethrower, and they kill all the bacteria, including very effective against Legionella. But different biocides kill different ways. They kill different types of bacteria. So we alternate that oxidizer with a non-oxidizer. But the oxidizer feeds 3 to 5 times a week, 3 to 7 times a week, or continuous. The non-oxidizer is fed 1 to 3 times a week. And it kills in different ways. Now, the nice part is your controllers are set up to feed however we've decided to feed your biocides, for how long we feed them, based on how much water there is, the type of water, what we're looking at. What we've asked the staff to do is once a week minimum, test your free available chlorine levels, so your non-oxidizers, in the cooling towers. Now, the trick is, because we're feeding it on a slug feed, which is the most effective, and 95, 98% of places feed that way, you have to measure it 1 hour after the chlorine feed is done. So you have to know when the chlorine feed is. And Alan, I'm sure, has worked over through with all you guys. So yours feeds at 8 o'clock in the morning and it feeds for 30 minutes. So at 8:30, it's done feeding. So at 9:30-ish, you need to go test the chlorine levels. And what you're looking for is 1 ppm of free available chlorine 1 hour after the feed is done. That means we've held at least 1 ppm of free chlorine for an hour. And we do that 3 to 7 times a week. And that really keeps your cooling tower much cleaner and more effective. Any questions so far?
Hi, this is Rob from the Aberdeen Regional Hospital. We test our chlorine, our free and total chlorine levels at like on the days that we pump, and we are consistently getting about 0.5, and it doesn't seem to matter how much chlorine we're pumping in. Right now, we're running it for 50 minutes, and it's not going up very much. And oddly enough, on our second smaller tower, we're actually getting a high chlorine reading on the off days, but not on the on days.
That's unusual. Both of the things you said are unusual.
Yeah.
If you turn the chlorine pump up, it goes up. I mean, I do this all the time. So there's something odd with the system, not unusual. And that's why it's so important that you guys let us know that. Bernie and Alan. Bernie, can you make a note? Assuming you are there still. And if not, I've made a note, and we'll have Alan call you and discuss that and go over it with you on your next trip, because that's just weird.
Yeah, I gave him a little heads up there a few days ago. He is aware of it, and he's going to be on site next week, and we're keeping a log of it. So.
Oh, perfect. That's the best thing you can do, is be aware that something's odd, and then we'll try and figure it out. Perfect. Any other questions? Glad somebody asked one, so I know, because I can't see it. I was wondering if I was talking to myself here.
Yeah, here in the Eastern Zone, I believe the staff tests every day for chlorine.
Then you must be feeding every day. And there depends on where you are and which program you're on. We feed anywhere chlorine, we feed anywhere from 1 to 7 days a week, or you may be even continuous, because there are a few programs that we just feed low levels continuously. So if you're testing every day, are you getting residuals every day?
Yeah, that I'm just looking,
Yeah.
trying to find the test results here.
And chlorine's one of those things that, well, we test every day, but we test at different times. Well, you're going to get zeros all the time or very low, because there's all the chlorine that comes from the city is dissipated quickly. Okay, well, you keep checking, and if we'll have time at the end, we go over that one again. Because if you're checking every day, if you're getting residuals every day, then your program's running every day. Any other questions? Okay, feel free to interrupt at any point as we move on. It's just this was the one that I got the most questions last time. So, all right, dip slides and Legionella testing. I should not put these two things in the title because one has zero correlation to the other. Dip slides do not have any zero correlation to Legionella. You could have 1 billion colony forming units of total aerobic bacteria in your cooling tower and have no Legionella bacteria. You could have 10 colony forming units of total aerobic bacteria, and 10 of them are Legionella. However, it has been an industry standard forever that we do a dip slide, and some of the standards include it, some of them don't. So we do a dip slide once a week. You guys do a dip slide once a week. Pretty simple to do. You take the little cap off, you swish it around in bulk water, and then you put it in a nice warm, dark place for 2 to 3 days. And then you bring it out and you compare the bacteria on the strip to your chart. Now, cooling towers are not, like I said, there's all kinds of different bacteria in the water. They are not sterile environments by any stretch of the imagination. The actual number that industry says you can have before you have to even worry about it is 100,000 colony forming units of Legionella bacteria. Not Legionella bacteria, total aerobic bacteria. You guys are aiming for less than 10,000, which is 10 to the 3. If you get less than 10,000, there's nothing you should do. If at 10,000 to 100,000, if you get that on your dip slide, well, then you want to check your biocide program, make sure that the pails aren't empty, that the pumps are primed, that it's actually getting in. And if you get over 100,000, then you should do a quick online disinfection. And we'll help you with that. And you have protocols for that. Now, Legionella testing, on the other hand, if you want to know how much Legionella you have in your water, bacteria is in your water, then you have to specifically test for Legionella bacteria. The culture testing, which takes 7 to 10 days to get your results, is still the gold standard. qPCR is faster, but it measures both live and dead bacteria. Now, it's way better than it used to be. It used to just be horrible. There's some standards that still say, okay, we want you to use the qPCR and then the culture test so that you can get faster results. The culture test is what you guys are doing every 30 days. Come in and pick up a sample. We put it in the right bottles with the right reagents. We send it to Pynchon Laboratories, who's the best accredited lab, probably in the world, but definitely in Canada. and they test it. Now, because it's Pinchin and we have a good relationship with them, and you guys have a good relationship with them, they give us a heads up. After 5 days, Rafik and the people there can actually notice whether there's a serogroup 1 or serogroup 2 through 12. But serogroup 1, and again, with Legionella bacteria, I'm not sure if I cover this. When we test it, we test for serogroup 1, which is the most virulent, the one that most of the outbreaks have been traced back to. So we test for that separately. Then we test for serogroup 2 through 12, which are the next highest of the rest of Legionella. That's where most 99.9% of it comes from. I believe at last count, there was over 65, maybe 70 serogroups of Legionella. Now, Pinchin also does a test for total Legionella or other Legionella. Just to give us an idea, even though they are not considered Legionella pneumophila, which is the ones that 2 through 12 and those are. So when you get your results, it will say serogroup 1, serogroup 2 through 12. They add those two together and gives you a total. And that's the number that we're looking at for Legionella. Now, they will do a test that says other. If you have other, it might be an indication that your cooling tower is dirty and needs cleaning, or we have to fix your biocide program. But what we're looking for is total Legionella pneumophila counts, which is serogroup 1 and serogroup 2 through 12. And there's protocols in place in your water management plans what to do if we find that. Now, what are those corrective actions? I'm not going to get into exactly, but less than 10 colony forming units is normal, and there's nothing that you technically have to do. I've yet to meet any hospital that gets 10 and doesn't want to do a disinfection, but that's okay. It's not mandated that you have to. At 10 to 999 colony forming units per milliliter of Legionella total pneumophila, then you know what? Immediately we want you to increase your biocides, and within a couple of days, we're going to be there to do a disinfection and try to kill it. And if it's over 1,000, immediately want you to shut off your fans, if possible, to shut off your fans to stop the spread, and then turn up the oxidizing biocide. And then we're going to be there to do a disinfection and really probably going to have to do a cooling tower cleaning too at that time or very soon. The nice part is oxidizing biocides work really well. I have, of the thousands and thousands and thousands of tests that we do, we probably get about 3% total overall, if you're following the program, positives. And of those, I would say 99.9% of them after a disinfection are gone. Now, they come back, and that's a different ball of wax, and we're going to talk about that now. When we get a lot of, Terry, this is the third test in a row where we had it, we killed it, we tested again, it was gone, and now it's back. And what I've found, and we've found, not just me, when we get there, problem is that biofilm, and the systems don't circulate all the time. If you've got two chillers, well, one's running, it's circulating, the other one's standby, it's not running. Well, if it's not running, even with all the automation, and it doesn't get any biocide. So what we're trying to work with each place, and it's in your management plan, because it's all different. Work with your building management system to see if there's some way you can get all the pumps running. You don't need the fans running, but if you've got free heat or free heat cooling exchangers, heat reclaims, there's all kinds of places that water goes that doesn't necessarily circulate all the time. What we want you to do is figure out a way to turn on all the pumps so that all the water in the system circulates at one time. Let us know when that is. We will set up the controller so that it feeds the biocide and a little bit of inhibitor at that time. We want you to do that ideally 3 times a week, but at least once a week, we want every drop of water to see biocide. And that has, when we do that, almost automatically, almost instantly, that Legionella concern goes away or really, really reduces because it's that standing water where it hides. And then you fire up that chiller and boom, you get the Legionella. So by doing that is really, really, we found has helped. Check mark means we're done with that. Cars, like I said earlier, they're great big old air washers. They suck all the dirt in the neighborhood. And that dirt is what we consider suspended solids, mostly. Well, all the treatments and all the biocides are for the dissolved solids. The biocides will actually attach to those suspended solids that are there and drop out instead of doing their job. So that dirt hurts you and hurts us. So what we want you to do, if you don't have a good cooling tower filtration system, and there's all kinds of them, you know, like a 10-inch filter housing is probably not going to help you on a cooling tower, but a 30-inch bag filter, sand filter, you don't need to get into all the high-end stuff, but any filtration that you can add to your cooling towers will help. And that leads us to the easy part. Every one of your programs says Chem Aqua Services, which is a division of Chem Aqua, will come in at least once a year. Some places are twice, and clean and disinfect your cooling towers. They're dirty. All the stuff sticks to them. Their water trades over them. You know, the sumps are only the bottom. The sumps get dirty, but it's the rest of the cooling towers that get dirty too, and then the water flushes over it. So all the standards say that cleaning your cooling towers, physically cleaning your cooling towers, minimum of once a year, will help minimize Legionella and keep your towers cleaner and save water. And there's all kinds of advantages to it. So that's part of all of your programs. And last but not least, program is not worth the paper it's written on if you've changed people, if you've changed tests, if you've changed the types of equipment you have. It costs you absolutely nothing. Bernie does it with me all the time. Oh, could you put this person in on that plan? Oh, could you change this? They don't have that anymore. Or they got a new controller, so can we change their plans? We don't charge a cent for updating your programs. And then we just send you another copy updated and it's got a date. You're supposed to do it annually anyway. So if you check your plan and it's still got 2023 on it, you need to send me, is there any changes? You need to send Bernie. Is there any changes? And what are they? And we'll update it for you. So that's very important. And it's mostly the people because hospital people change all the time. Equipment doesn't change that often, but it can. Or we bought a new pump, or we bought not a pump, we bought a new controller. So we're doing things differently. Let us know. We want to work with you. We're part of your team. Now, Legionella bacteria.
We got a question from Andrew Young.
Okay.
What hospital are you from, Andrew? Anyway, the question is when you guys clean.
Yeah, no, mainly at the regional hospital in Cape Breton. That's the main one.
You guys
I
are
don't
so
see
much
as
trouble.
clean the other ones, yeah.
And your question would be?
Oh, when you clean the cooling towers, I seen the guys like scoop out the sumps and stuff and all that. But like when they're cleaned, they're not running. So like the nozzles don't get cleaned, the headers don't get cleaned, the baffles don't get cleaned. That's stuff.
Don and Bernie, you need to check with our Chem Aqua Services team. They should be cleaning the nozzles for sure.
The only reason they wouldn't clean them is if they would fall apart or something if we tried to take them apart.
I was told, I'm Courtney Kennedy. I'm the assistant maintenance manager for the Cape Breton Regional Hospital. Each year they're here, they say it's out of their scope of work. They don't remove the header, clean out the nozzles. So they're not covered to do that.
Oh, because the headers can break when they're taking them apart.
The headers
Not
will-
likely. It's 4-inch PVC pipe. There's
Anything
pretty.
can break when you take it apart.
Yeah. Is there any way you can work with the guys when they do come over to take those apart? Because
I requested it this time, and they said that they spoke to their manager, whoever that may be, and they told them not to do it.
Okay, leave that one with me.
Yeah.
Okay.
It's Courtney.
that's your small tower, Courtney.
Nope, the large and the small.
Oh,
So
both.
3
of them.
towers altogether.
Last I heard, they're supposed to be cleaning the nozzles. That's part of the deal. Leave that with me. I will check with our Chem Aqua Services Department. And again, they're humans. Sometimes there's miscommunications, but we will find out for absolute positive, sure. And we'll get back to you on that.
That's great. Thank you.
Great. Thanks, Courtney. Any other questions on Chem Aqua Services? I usually get a few on those too. Okay. Now, that Legionella bacteria cannot be eradicated. However, I love this. CDC actually made this slide and they sent it to everybody, probably 3 years ago. In 9 out of 10 investigation shows that almost all outbreaks were caused by problems, and outbreaks of Legionella were caused by problems that were preventable with a more effective water management plan. So there are things that we can do to minimize it. I love to see the standards. They're all pretty much the same. Canada's really, really good at it. New York and a few of the states are good. Europe is crazy on it. They can go to jail over there. But in Canada, we've got some pretty good standards, and you guys are doing a really good job. So the good water management plan is definitely the first step in minimizing Legionella. And that's the end of our presentation. Oh, I'm good. 15 minutes left. I'm going to stop sharing. Try to stop sharing so I can see everybody. Oh, there they are online. So we've got a couple minutes left. If anybody has any questions, and if not, I know you guys are all dying to spend 15 minutes chatting with us, but
Yeah, I
Okay.
checked it
Oh.
in the cooling tower, free chlorine, the staff, they tried to measure the free chlorine daily. I know on our management plan, it does say minimum of once per week. So should they be doing it daily? You would think that would be better
Which
than once a week,
hospital?
because if once a week is missed.
Robert's in the Eastern Zone.
Eastern Zone, assistant manager, maintenance systems for Eastern Zone.
Okay. If you're not feeding it daily, if you're feeding it 3 times a week and you're testing it daily, it's a waste of time, energy. You can do it. What we're trying to do is if you're feeding, we want to make sure that you guys understand you got to feed it, you got to test it 1 hour after it's done feeding. Otherwise, the testing is pointless because it can be anywhere and there's no thing to it.
Yeah, I'm not
So
familiar
let's
with the
just-
controllers, but aren't the automated controllers that feed automatically?
Yeah, but they're set
I
up
don't
on
even know that. Right.
they're set up on a timer for the biocides.
Oh.
Probably because most of our plans are 3 to 7 days a week. So it's Monday, Wednesday, and Friday at 9 o'clock. That controller comes on and feeds the biocide for 35, 45 minutes, which you guys should know because you're doing the Legionella testing, or not the Legionella testing, the chlorine testing. So if you're not, when Alan's in, have him walk through with you. And that's part of our deal too. We'll take the time. I know we don't always hook up and there's times that it can't happen because everybody's busy, but take the time, especially if you're doing testing for no reason.
Okay, so
And
the system
you're
doesn't.
gonna get bad results and then everybody's gonna go, oh, we have no chlorine. Well, we're not supposed to at those points.
Okay, so the controllers don't measure the chlorine like an ORP system.
Well, some of them have ORP, but again, Chem Aqua does not believe ORP
Okay,
because, well, we believe it. We like it. We use it to monitor, but I won't use it for controls because it's just so finicky. And if it gets out of whack, you can grossly overfeed very quickly or underfeed very quickly. And then there's all kinds of problems. You start chewing chillers up. So we can use the ORP as if you've got it on your controller, great. It's a good way to verify that you're feeding the biocides, but it is not the way to control them. So I've seen somebody else texted a question too.
I think, Robert, we've set up most of your controllers to feed chlorine 3 times a week and the non-oxidizer the other 3 days a week. So I would only test for chlorine on those days.
Have Alan can you have Alan do a training session there with them? Go over it with them in person. Okay, great.
Yeah, that'd be a good idea.
Question. Yeah, training is part of, these are nice, but on-site training when Alan's there is far more important. Where's the chat? I've seen somebody talking on the chat.
There's a question, is too much chemical a problem or just a waste?
Thanks. Oh, George is here. Thanks, George. Too much chemical is just a waste of chemical. If you're supposed to feed inhibitor at 100 to 125 ppm, that's what it works at. It does not work better if you feed 200 or 225. It does not work any better. Biocide, once it's got its kill and you've got your 1 hour of free available chlorine, there's nothing else to kill, so it does nothing. You're just wasting chemical. But a little overfeed is not, and it's not going to hurt you. If you grossly overfeed, and I mean grossly overfeed the oxidizing biocide, it can chew up copper and stink and all kinds of different things. Great. Any other questions? And I'm pretty sure you guys all have a whole lot of, whoops, we got one more.
Hello, this is Jim from Dartmouth General Hospital Central. I have a quick question. We're using the chemical feed system for our cooling towers. Do you guys have any kind of scale that we can put under the chemical jars so we can take the reading for the jars each time when we do the run check, so we know that chemical is actually being pumped into the system? Because sometimes the pump does lose prime, and I asked my guy to check the prime, but I'm not sure whether they actually do it or not. So if there is a scale, we can take a reading every time. So if we see some difference, we know the chemical is being pumped.
Yeah, there are pieces of equipment that you can attach to the pump that will measure the actual chemical going through, but they're expensive and they break and they get clogged up, but that's okay. They work. That's why we're asking you guys to test. If you're only feeding chlorine and a non-oxidizer, and chlorine will quite often, of all the chemicals, you'll lose prime. But you can see it going through, you can feel it going through the line, so you should know. And if you're not getting your chlorine residuals, let us know and we'll figure out what's going on and why.
All the controllers that we set up with chlorine feed had the 5-function valve, which automatically bleeds so that you don't lose prime in the chlorine.
That's good.
If those are working properly, you shouldn't really lose your prime unless you run out of product.
Yeah.
Rob from the Aberdeen, we were having the same issue with just one of our chlorine pumps losing prime. So we physically go down. I physically go down and make sure that the pumps are primed, because one of them does lose it. And I was found that when we set up the kit, the pumping station, it comes with a soft hose. And if we lose the prime on the pump, we were losing the prime on the pump where that soft hose was hooked up as our feed from our chemical pump up. So when we replaced that, so that was I switched it so that it became the bleed line, like it was directed in the instructions, and that really helped stop our pump from losing its prime. But the best way to do it is just physically go down, force the pumps on for a few seconds, make sure that the line going up into the system is actually pulsating really well, and then we know for sure we've got, that's best practice here for us.
There you go. Never use that soft line for the feed side. That's just a return and maybe a suction.
Yeah, just for suction and priming.
Yeah, no, I meant, sorry, no, on the suction side, that's what it was on. We were losing the prime there, not on the feed side. Yeah.
Okay, good.
Yeah.
Okay, if that helps, great. That's good. Anything else? Okay. Gentlemen, you still got a couple minutes to get back to work early or have a break. It's not up to me. I don't get to decide what you do. Thanks a lot. We really appreciate your questions. We're there for you guys. If you need anything, let us know. Bernie's pretty quick on answering. I'm available. Alan is really good at what he does too. So thank you much for your time. We really appreciate it. And we will see you soon.
Thanks, guys.
Thank you very much.
Okay, thanks.
Yeah.
Thanks, everybody. Thanks, Rob.